Hello, I'm kimera eriasaf and I'm presenting my project. My project is fake news detector. As in, I'm trying to create a fake news detector to detect fake news and it can tell people that whether the news are fake or they are real. My explaining my problem is fake news, and fake news can refer to false information or reports. It can be in the form of articles, images, or videos which are disguised as real news, but they aim to manipulate people's opinions. Like an example I can give, like when someone posts on Facebook or social media, any handle, and it's posting something that is fake, like it can manipulate people's minds. Like they can start to abuse someone for no reason. Like let's say that the person did something and that thing is not like the person has not even done it, and people will start abusing that person for no reason because of that thing the person has posted. It has consistently been growing around us, primarily as clickbait. Clickbait can mean something like, as I've explained, that when someone posts on social media, then clickbait can mean inviting a lot of clicks. Many people will start clicking on that link or that thing, commenting, liking, abusing, and that's a clickbait, and often trends to go viral. And it will go viral. These articles and stories created mislead and misinform people into believing narratives that hold no merit. The dataset that I'll be using, that I chose, it's a fake and real news dataset. The dataset has, how I'll be using it, it has files, like, I'll be, I'll be, I'll, it has two files, the fake CSV and the true CSV. Like, I'll be storing the fake articles, I'll be writing the fake articles into the fake CSV, and the real articles into the true CSV, and that this way it can help to inform people that when someone posts and he uses this detector, it can tell him that the thing is fake or if it's real. And the factors that I considered before choosing this dataset, and then I considered the installation process. Like it did require me much time or energy to install it, and there were no much restrictions on it. Like you have to first sign up, you do this and that. That's it, and it made me like to go with that. But then the size of the files in that dataset, like their size was small in MBs. Like they they too the size of those files, the capacity of those files, the size was small, and since the size was small, I was able, and I liked it. I said I had to go with this one because there was a data set that I went to, but it had the capacity of the size of the files, the storage size was high. It was something like 120 something MBs, and I said this one I can't manage. It has a higher capacity. Therefore, I decided to choose this one because the capacity it had was small. And that's it. And also, I considered whether the dataset was public or private. And private dataset they have a few information, but public ones they have a wide range of information, and they come from organizations or businesses that are open enough to share. And I decided to go with this one, but I can change. I'll be adding other information in it also. So I went with this one, and the important features that I found in this database: the title. The title is the heading of a news article. Then the text is text explaining that heading. Then the subject. The subject shows if the article is political or economic or social. And the date shows that this article was published there. And describing Bayesian theorem. Bayesian theorem can be regarded as Bayes' theorem, and it states that the condition probability of an event based on the occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first one. And we can also describe it as the posterior probability, meaning the probability of an event given the new information received is proportional to the likelihood of seeing that new information multiplied by the prior belief. Also, naive Bayes, explaining naive Bayes is a supervised learning algorithm, but it's based on Bayes' theorem, and it's used for solving classification problems. And it's mainly used in text classification that include high dimension training datasets. And naive Bayes, continuing, you can also describe it as a probabilistic classifier which predicts on the basis of the probability of an object, like it predicts on the probability of an object. Like if the probability, let's say, is high, it predicts based on that thing that highness. If it's low, then it predicts based on that lowness. And also you can describe it as one of the simple and most effective classification algorithms which help in building the machine learning models that can make quick predictions. Then explaining Bayesian networks. Bayesian networks sometimes can be called Bayesian belief networks, and this one allows users to specify which attributes are in fact conditionally independent. So Bayesian network, explaining it, is a type of probability graphical model that uses Bayesian inference for probability computations. And Bayesian networks aim to model conditional dependence and therefore causation of representing conditional dependence by edges in an elected graph. An elected graph can mean a graph with edges and it's showing you the direction that you should follow. Like it has those arrows that tell you that you have to take this side, this side, this side. So to reach the end, to reach where you want to go. So that's an elected graph. And you can describe Bayesian network also as a dilated acyclic graph in which each edge corresponds to a condition of dependence and each node corresponds to a unique random variable. Also, continuing explaining Bayesian networks, but this time using an example. Like if an edge AB exists in the graph connecting one of variables A and B, it can mean that the probability of B given A is a factor in the joint probability distribution. So we must first know probability B given A for all values of B and A in order to conduct inference. And Bayesian networks satisfy the log Markov property. The log Markov property states that a node is conditionally independent of its non-descendants given its parents. And explaining the difference between naive Bayes and Bayesian theorem. Naive Bayes assumes conditional independence, where Bayes' theorem does not. And this means that the relationship between all input features are independent. Also, the naive Bayes classifier is an approximation to the Bayes classifier, meaning to determine To meaning naive bias, it always approximated to bias classifier. Like to determine naive bias, always you have to first determine bias classifier in order to get naive bias. So we assume that the features are conditional independent given the class instead of modeling, therefore conditional distribution given the class. So bias classifier is the best interpreted as a decision rule. A decision rule can mean like you always have to take a decision. Like to do this, I have to do that. So I have to take this decision. Also, different giving a difference between naive Bayes and Bayesian networks. Naive Bayes assumes conditional independence, like let's say probability of x given y and z equals to probability of x given z, and whereas Bayesian networks will allow the user to specify which attributes are in fact conditionally independent. Also, for any, these are the references. The references where I got my data. So for anything, you can go and paste these references. These references, the references that I listed. So for anything, you get like this sciencedirect.com topics mathematics Bayesian. It's where I got the Bayesian network, the definition, and these technical factors consideration choosing dataset. It's where I got those factors that I wrote down, and this calco, this dataset that I used in the fake and real meat dataset. This is the link in the Clement Besalon. It's where that I got that dataset, and then this stack exchange. It's where I got the difference between bias classifier and the naive bias classifier. So for anything, don't forget to subscribe to my YouTube channel, and don't forget to click the notification button in case I post a new video. You can get notified quickly and you can watch it. I still remain Chimela Eriasaf. Thank you.